So thanks so much for attending. I'm presenting today joint work with Oscar Fantanes, who's also here in the audience. And so what we're presenting today is a paper on growth in the firm size distribution over the long run. And we start this paper drawing on 40 years of Indonesian manufacturing firm panel data. And we show basically three things. So we show that that output in manufacturing grew 25-fold over this 40-year time span. We also show that the average firm size doubled over this time period. But this is not just a uniform shift in the entire firm size distribution that we observe, but we also especially see that the right tail of this distribution is growing bigger over time. Okay. When I talk about firm size here, I mean the number of workers of a firm. Okay. And in this paper, we're asking basically two questions. First, what are the drivers of this huge output growth? And also these changes in the firm size distribution. And then specifically, we ask, what is the link between these two? Okay, is there a causal link between the growth and the changes in the firm size distribution? And to answer these questions, basically we proceed in three steps. In the first step, we start with a formal growth decomposition exercise. Okay, that's a statistical exercise that formally decomposes aggregate growth or output growth in manufacturing. And based on this exercise, we find actually, and surprisingly to us, that aggregate productivity plays no role in this output growth. In the second step, we are then wondering, okay, what is driving this huge output growth if it's not aggregate productivity? And we are kind of trying to distinguish between two sets of factors. One is kind of policy changes over time. Think of kind of moving of static equilibria over time, policy changes that are kind of improving the allocation of firms, reducing misallocation, something like this, and that's driving output growth. An alternative explanation could just be transition dynamics. What do I mean by this? It means fix the initial distribution of firms or the economy, fix the policy environment at the beginning of the data, and then just let the economy kind of play out. And that could also drive some of the growth. And based on an exercise we propose here, we actually find fairly strong evidence that transition dynamics are important in this data. And so then to kind of put these things back together, we build a structural general equilibrium model to understand the drivers of growth and also the changes of firm size distribution, but also that helps us quantify the different mechanisms. And in the model, in the structural model, what we have is that endogenous transition dynamics are driven by mostly firms being below their optimal size. And that slow growth is due to convex adjustment process. Okay, so what do I mean? There are firms in the model, say, take the initial time period of the data, 1975, there's a firm size distribution. Most of these firms in this distribution are below their optimal size. And they want to grow, but they actually only grow slowly because of these convex adjustment costs. They just cannot grow large overnight. Okay, and kind of in combination with this in the model, there's going to be endogenous structural change. Resources are being reallocated from other parts of the economy to manufacturing, but this process is also slow. Okay, and so kind of the key takeaway from our paper is that what we observe is that there's an initial distribution of firms that lacks large firms, and because it just takes time to grow large firms, this can explain long-run growth even over multiple decades. Okay. So now kind of I'm trying to kind of break up a little bit the three different parts I showed you to kind of make sure that you at least don't think this is kind of magic what we're doing here. I'm going to kind of go a bit faster on these things. But so the first part was the growth decomposition exercise. This is kind of basically the formal accounting identity that we use. So we use the GDP growth on the left-hand side. That's explained by a composition of facts. There's growth in aggregate productivity, there's growth in total inputs, and then there's growth in a combination of terms that are selection and reallocation effects. Okay. The main results from this growth decomposition exercise is that we find that aggregate productivity growth in our data contributes less than 4% for the entire growth that we see between 1979, the beginning of our data, and 2015. Most growth comes through inputs. Okay, so inputs are increasing. That drives about 70% of the growth. And then there's a combination of selection and reallocation that account for the remainder of this. And both of them contribute in roughly equal shares. Okay, how do we come up with these numbers? Where do we get this? Do we get these from? Kind of the two key ingredients in this accounting exercise is that we have to make an assumption on a production function, and we have to estimate this production function. Okay, so that's a key part. And one kind of key restriction that we do is that we only focus here on labor. Okay, because labor is this, we observe labor for the entire time period. And we don't, in capital, we only observe for a much shorter time period, and it's much noisier on the data. But then based on this, we have a production function estimation that also allows for fully dynamic input choices. And then the second kind of ingredient to this growth decomposition exercise is that we separately identify aggregate and idiosyncratic productivity. So aggregate productivity is a term that affects all firms in the same way. That's how we normally think about kind of the state of aggregate technology or institutions. And then idiosyncratic productivity, that's idiosyncratic firm productivity. And we have a novel identification strategy in this paper to separately identify these two. Now, the second step I showed you before is that we try to kind of disentangle now what is driving actually this output growth. And we propose an exercise that we also revisit in the structural model is we say, okay, let's suppose to tell policy changes and transition dynamics apart. What we want to do is we say the idea is to fix the policy environment at the beginning of the data. And we are wondering how predictive is future growth and firm dynamics just based on the initial distribution. Okay. And this exercise should give us some idea of the importance of transition dynamics. Okay, because we are explicitly only taking information from the initial time period, so we cannot infer the role of future policy changes. And the reduced form exercise we do here is we fix an initial transition matrix of firm size changes that is only based on the initial time period, and we iterate on this initial transition matrix using the initial firm size distribution. And we find that actually the long run evolution of the entire firm size distribution and also the output growth of firms explains about 70–90% of this we can predict just based on this initial data. And in the structural model, we replicate this. Now, let me briefly talk about the structural model. So what we do here is it's a two-sector model. We have manufacturing with heterogeneous firms, and then there's a restive economy sector with a representative firm. Okay. The interesting stuff happens in manufacturing with heterogeneous firms. There we have firm production with aggregate and idiosyncratic productivity, as I had before. There's structural change in the model because there's labor reallocations across these sectors. Okay, and then what we have is the key risk, kind of the key constraint, the key kind of driver of dynamic effects over time is that the firm size, firms want to choose their labor inputs, but they face adjustment costs. Okay, and these labor adjustment costs, they can be very flexible. There's a combination of fixed, linear, and convex costs, and they are going to determine a lot the dynamic movements over time. Now, the main insight from the estimation of this model using microdata, we find large convex adjustment costs. Okay, these convex adjustment costs, they are identified not from the aggregate dynamics, but they are identified from micro-level policies that we observe in the data. Okay, so we are not saying, okay, what kind of policies would we have to estimate to fit output growth in the end, but rather we say, okay, what kind of policies, model implied policies do we need to fit the observed policies of firms in the data? And from this, we infer that you get slow aggregate transitions. You just have very few firms that grow very rapidly, that choose a lot of labor in a short period of time. And so this is what we infer from the model. We find that that's our main takeaway of the model, is that this initial distribution lacks large firms. It just takes time to grow for firms, and that leads to long run growth in the model. All right, let me stop here, and then we can take some points for discussion.
Thank you, Jonas. If any of you have any questions, please raise your hand or just ask.
Quick question. This is Paco Huera. Do you hear me?
Yeah, perfect.
But, yeah. So one small comment on language at the beginning. I understand what you're doing after a few slides, but we'll not call it the first time aggregate productivity to the extent that, I mean, you might think of doing a simple TFP accounting. That's not what you're doing, obviously.
Right.
So I guess you say you can econometrically identify a common component versus a idiosyncratic component and play them out. So that's my minor comment. But then I'm more curious about when you say that you identify policies explicitly that drive this slow adjustment. Can you be more specific about that?
Right. So what I meant.
So it is just a technological feature that you tell me that the model, given the technology of adjustment costs, imply very slow dynamics, or is something else?
No, that's that. So sorry, just to be clear, maybe that's a bit bad choice of vocabulary, but when I talked in the very beginning about policies, I meant like political policies, and later on when I talk about the model, I meant model policies like optimal choices by firms.
Will be example of these political policies? Sorry,
say this again.
What would be an example of the policies that are driving the slow adjustment that you identified?
Oh no, okay. So yeah, so in this exercise we cannot really say much about what is exactly driving slow adjustment. Why do firms not grow super large overnight? Right. So I think this is basically, think of our paper as kind of the CEPR 2014, that you see kind of slow life cycle growth of firms. Think of this in a dynamic setup where you have kind of equilibrium and transition dynamics over time, but it's kind of replicating exactly that. And the same reasons that were given in CEPR 2014 of why you might see kind of slower life cycle growth of firms in developing countries, the same reasons here. It's just that what we are looking at is a dynamic setup where you have these equilibria over time, the path of equilibria and transition dynamics.
Yeah. If I can come in and follow up on the previous question, actually. So are you saying that policy has no play in entry and exit of firms?
Right.
So you're saying, in a sense, I don't find that too convincing. It's to give an example, in the countries like India, for instance, it's a well-recorded empirical fact, that observation research, that factory acts, after 10, a lot of laws kick in, and you see a huge drop in the number of firms. Then you have the Labor Disputes Act and so on. So again, a bit more clarity on that. But
no, that's a super fair point. So let me be clear on, and I think you're exactly right to point at one weakness. But so first, I want to be clear that we are not saying policies don't matter. What I'm saying is what is driving output growth. Like you see over 40 years, you see a 25-fold increase in manufacturing output. What is driving this? Now, what we are just saying is fix a policy environment. Policies can be super important here, but fix the policy environment. And from this already, you get a lot of growth because of transition dynamics, right? I'm just saying you should take away from this paper that you don't need a lot of policy changes. You don't need a lot of kind of changes in wedges and misallocation and so on induced by policy changes over time to get the growth we observe from the data. That's the first part. The second part is you're exactly right, that entry and exit here. So exit is, we have this endogenous, but entry we take as exogenous so far. And this could be largely driven by policy over time. And so we are looking at this at the moment to kind of endogenize entry and to think of kind of how policy matters for entry as well. This is a great point, and this is spot on.
Right. But the other observation is, if you can give us some idea of what you mean by large and small firms, the number of workers, and heterogeneity. See, it's someone like Haltiwanger in the US.
Right.
He makes a big point of firm heterogeneity and productivity, and he narrowed it down, and that's the big difference between developed countries and non-developed countries, right? So what is happening in Indonesia in terms of narrowing down the heterogeneity and productivity?
Right. So I have to be clear. So the data we work with is actually only working with medium to large size manufacturing firms. Okay. So the cutoff of this survey is 20 workers. Okay. So these are already fairly large manufacturing firms. Right. But when we scale this later, when we compare the rest of the economy to manufacturing, we take the true size this sector has in the economy. Okay. But so what we have here is that this is kind of 20 workers, and then kind of large firms here are firms that have maybe above 500 workers. Okay, that's what I mean by kind of large. And it's just that in 1975, there are just very few firms that have more than, let's say, 1,000 workers.
Hi, I have a clarifying question. So it's the adjustment costs that make the model dynamic. And then related, you have three types of adjustment costs: fixed, linear, and convex. And it's the convex adjustment costs in particular that make the model dynamic.
No, so all of these adjustment costs make the model dynamic. But what really matters for the long run transition are the convex costs, right? So if you think of kind of the fixed costs or the linear costs, firms might just not adjust, right? They will stay inactive, they will stay with the number of workers they have. But the moment they're willing to pay these costs, if you didn't have convex adjustment costs, they could grow, you know, from today's size to kind of size of Amazon overnight, right? But convex adjustment costs, that's what's kind of really preventing these firms from growing fast in a short time, right? And it just matters that because in the data, you observe firms just growing slowly. So you need convex adjustment costs to explain the slow growth. Does that make sense?
Yeah, thank you.
Now you can ask follow-up if you.
But the adjustment costs, are they endogenous in your model? I mean,
Sorry, what is endogenous?
the adjustment costs.
No. So yeah, so I think that would be a next step. So first, I think a lot of it is kind of an accounting kind of step. What do we need to get exactly the kind of changes we observe over time in the data? And now I think we kind of want to unravel a bit more of what are these adjustment costs? What exactly do we think of these convex adjustment costs being? And what part of this is kind of maybe policy variant, right? So I think we're going there. That's the next step. Yeah.
Can I ask a quick question since they are not closing that room?
Please,
Do you
please.
actually see the firm age in the data?
Yes, we do.
Okay.
So
I'm
not for all
asking-
years, but yeah.
Okay, so I'm asking because obviously I'm talking about different data. So I looked at data from the industrial policy period in Korea, 70s and 80s, and some of the findings are very consistent with your finding in the sense that the firm size really increased, mostly driven by the right-tail activity. And then there actually is a plant size. And then what we find is that in that case, a lot of these really large firms are new entrants. So the policy comes in place and you suddenly see really big plants popping up. So that obviously, again, is a different policy environment in different countries. So I found it interesting that it's mostly about the convex adjustment because that takes a long time for firms to grow.
Right. Yeah, so I don't think this is what we observe. So I mean, kind of the slight problem in our data is that there's this cutoff. So we only observe firms once they have 20 workers. But it's not that the moment they enter our sample, they are suddenly already 500 workers. They start entering our data when they're small, around 20 workers, and then they grow slowly over time. So it's not that kind of the new entrants are suddenly directly at 1,000 workers.
No, I mean, also it's consistent, right? So one could have, even in my data, it's plant level. So I think you could have an old firm that suddenly added a really large plant. So that doesn't count as a new firm, right? So it's still old firm. So
right.
I think there's some difference between them, but really nice work. Thank you very much.
Yeah. Can you send me that paper? So if you, that I would
sure, I'll be happy to actually. There are some interesting empirical findings that coincided with yours. So.
Great, thanks.
Thank you so much, Jonas. I think that's all the time we have. I see the other groups are all finished now. So thank you very much, and thank you for all your questions.
Thanks.